So in the starting, we just go with the basic functionality of how the LED is and how we can just see with the connection part for the LED. Next, for the LED interfacing, we will be requiring these components: the Arduino Uno with the USB cable, LEDs, jumper wires, breadboard, and 220 ohm resistor. Fine. Now this is the basic block diagram, and I was referring to this point why we are using the pin number 3, 5, 6, 9, 10, and why not the 0, 1, 2, 3, 4, and the any random combination which we can use in this case. The thing is that uh, like we can use any pin for if you just want to interface the LEDs only. Fine. This 3, 5, 6, 9, 10, 11 are the PWM pins which we have learned in the yesterday's lecture. Like whenever if we want to control the intensity of the LEDs, we can use the PWM functionality to control that feature. And that is like in this case, just a second. So in this case, like in Arduino Uno or the Nano, we are having pin number 3, 5, 6, 9, 10, and 11 with the PWM functionality. Fine. And that is the main reason why we are using these pins only. And in the coming lectures, I might be avoiding this pin number 2 and 1, 0 and 1 for the use of these LED functionality. We will be coming to that reason as well when we are going to like interface multiple devices. Why we are like I usually avoid to use pin number 0 and 1. Other than that, you can use like if you were just going to use with the LEDs, then pin number 0 to 13 you can use anything. Fine. So let's see the connections. Like for this, you will be first requiring to put the LEDs into the breadboard. Then you can connect the 220 ohm resistor with each cathode end of the LED. And the first end will be connected to the LED, and the second end will be connected to the ground rail of the breadboard. And the ground rail of the breadboard is connected to the ground of the Arduino. Fine. Then we are just connecting the anode of the first LED to the pin number 3, anode of the second LED to pin number 5, of the third LED to pin number 6, of the fourth LED to pin number 9, of the fifth LED to pin number 10. You want to use 2 LEDs, you can use 2 LEDs. You want to use 10 LEDs, you can use 10 LEDs. Like just with the reason, like why we are using this like specific number of pins is of the because of the PWM functionality which we are going to learn today itself. Fine. So this was what we want to have, like to put the interfacing of these LEDs, the connection part. Now let us move towards the coding part for this. So the first code uh, to basically like test for the LED is we are going to turn on and off the LEDs one by one. So what I mean to say is this LED will be turned on first, then it will be turning off. This will be turning on, then off, on, off, on, off. So this is our first exercise which we are going to learn today. Fine. So let us just go and see how we can code for that. So we are here in the while loop in the new page of the Arduino IDE. So as we have known, like the void setup section will be helping us to basically tell the Arduino which pins we are going to use and what are the purpose of that event, whether they are to be input, whether they are going to be output, or if we are going to start with some serial monitor, if we are going to start with any library in that or not. And this is the void loop section will be going to be a logic area. Fine. And the next thing is like the void setup section will be running for the once on for a single time only, and the void loop section will be continuously running for the infinite loop. Fine. So let's just start with this. So in order to basically first define the thing out, like which pin we are going to use and what the mode that pin will be used for. Like if I suppose to say if we are going to use the pin number 3, then we have to tell Arduino, yes, we are going to use the pin number 3, and also we want to tell that thing out whether it is going to be an input or whether it is going to be an output. Fine. So let's just start it. For that, we need this command, this function basically, pin mode. Just make sure with the letters as well because it's a case sensitive language. So it's pin mode and like it's a function. Now it's this function will be going to take two parameters. The first parameter is the pin number and the second parameter is going to be the type, the mode, basically it whether it is going to be an input or whether it is going to be an output. So in our case, since we are going to interface an LED which is going to be an output device, so this pin will be going to be an output. In similar way, we are going to code for the rest of the pins. So it's pin number 3, 5, 9, and I guess it's 10. Let me just verify this thing up. Yes. So this was done with the first part. Now we have told our Arduino to basically like we are going to make these pins of use in the programming, and then these pins are going to be in the output mode. Now in the logic section, what we are going to do is we want our first pin to turn on, and then we want then it should be turning off, and then the second pin, which is the pin number 5, should go on. Fine. So let's just do that. For that, like to whether to turn on or off a single pin, what we require is we require this command. It is digital write. This is the function, and this is also going to take two parameters. The first parameter is the pin number. So in this case, it's pin number 3. And the second parameter is the mode, whether it is going to be in high mode or in a low mode. Fine. So like we want to see that pin to be in high mode. So we have put that thing into the high mode. Now, if we want to see that change, like we remember the thing that the clock speed of the Arduino Uno is of 1600 megahertz. So when we just divide that 2 by 1 by 16 into megahertz, that is 10 raised to the minus 6. So that is much of 1 by 16 into 10 raised to the minus 6 seconds. So it is too fast to see the change out. Fine. So for that reason, we require to have a delay in it. And in the yesterday lecture, we already know that this delay takes the value of the time for which we want to suspend the program to go into the next command. Fine. And like this is also going to take a single parameter, and that single parameter is the amount of time we require to put that delay, and that value is in the milliseconds. So for a single time for a single second delay, we require a value of 1000 in that. Fine. Now what we require after this delay, we want our pin number 3 should go to low, or should the pin should go, the LED should turn off. So what we are going to do is we are just going to tell Arduino that thing out. So this is how we basically turn on something and turn off. Now, like in the yesterday lecture, we already seen how the LED is blinking, and this is almost the same code for that. Now, in this case, what we are going to do is we are going to repeat this thing for the rest of the pins as well. So let's just copy this code up. We have the pin number 5 going to do the same function. Then pin number 6 going to do the same function. Then we are having pin number 9 going to do the same function, and we are having pin number 10. And this is going to be our last pin. So, and this is also in a loop. So what we are going to do is we are just going to put another delay so that we are able to see that the pin number 10 is off. Fine. So it is just, this is the code to basically turn on one by one a single LED. Fine. So let's just save this up first and verify this for our code itself. So like before verifying, you must have remember that thing out. In the tool section, you have to check for the Arduino, and in the port section, you can check for your COM port as well. So like we are going to code for the Arduino Uno, so it's perfectly fine. At present, I am not connecting my board to it because we are going to use this simulator for this purpose. So we just want to verify if there is any mistake in our syntax or not. Fine. So it shows done compiling, which means we haven't done any kind of mistake in it. So let's just move towards the Tinkercad online platform for the simulation. So in the simulation section, like in this is the basic overview of like how the Tinkercad platform will be looking like. And in the all sections, when we put, we can just type for Arduino. And in the starter section, you can have Arduino with the breadboard. So just a drag and drop, and you can see we are having the Arduino and the breadboard. Now what we require, as we have seen in the PPT, we require LEDs, and in this case we are having around 5 LEDs. So let's just first use this first one and put a resistor to the cathode end, and let's just change this value to 220 ohms. Now let us copy this up, paste this thing. Fine. So this is how we go with the connections out over here. Now what we require to connect the LED pins to the Arduino. Now this is the anode of the first pin. We're going to connect this thing to the pin number 3. Now let's have another pin out. Okay, so let's have another one. We are going to connect that to pin number 5. Let's have another one, pin number 6. Pin 9 and pin number 10. So this is what we require for our interfacing. So let's just copy this code up, go to the code section, then choose for text only, continue, and just replace with this to your code. Now
So
let's
ground wire is not connected. So.
it's connected actually. We are, that's why I use that cater section. Like we already have the connection with the ground. I have put it this LED, this resistor into the ground line only. Is this clear? Like this is the ground's connection from here, and we have connected that to the other rail as well. So we can use any rail for the ground.
Okay, sir.
Clear?
Okay.
Like you can use any ground. You are having two grounds over this side. You are having one ground over this side. You can use anyone. It is all three are being internally connected. So you can use anyone. So if you want to use this one, you can directly use this as well. No issues with that. But it's already been connected, so it is not going to put any difference with that. So let's just start with the simulation. So you can see one by one each LED is turning on and off. And after that, with that delay, with this extra delay which we have put it, the system goes for a off state for a 1 second as well. You can see this is that 1 second delay. If we just remove that thing out, you can go with this as well. There is no delay now. in the loop section. So that is why when we say about this void loop is basically the infinite loop. It is going to be running for no, like for infinite number of times till the time there is a power to your device. Fine, because we are not going to put at this time at this moment we are not putting any kind of restrictions to this loop. If we put that up, then we can also reduce these things to a finite number of times as well. Fine. So if till this point, if there is any doubt, you can ask. Otherwise, we can move to the next example. Any doubts?
No, sir.
Okay. So in the next example, what we are going to do is we are going to code for a thing like we want to turn on the whole LEDs first in a row, and then we want that these LEDs to be turning off one by one in the backward direction. Fine. So let's just like what we want is like first this LED is going to be turned on, then this, then this, then this, then this, and these all are turned on for the time. And when the last LED is turned on, these are going to be like will be turning off in a opposite manner. Fine. So let's just code for that. So till this point, like we are going to have a same code. We are going to turn on the first LED. Then after a delay of 1 second, we are going to turn the second LED. Let me have this for 5 times. 1, 2, 3. So what we are doing there? 5, 6, 9, and over here we're having 10. So what it is going to do is it is going to turn on 3, then it is going to turn on 5, then 6, then 9, and then 10. So in this way, our all the 5 LEDs will be turned on after this 4-second delay. Then this is for the on time. LEDs on, and then for off, LEDs off. So like if you uses this slashes 2 times, you can use for the command section that is not being included for the compiler to be checking for any errors. Fine. So this is basically help for the debugging purpose. Now what we are going to do is we're just going to copy this thing up, and then we are having 10 over this side and a low. So first the 10th LED will be going to be low. 10, 9, 6, 5, and 3. Fine. So this is our code. Let us see what is the difference with this code. Let's just copy this up, paste over here, and let's just start. So see, you can see the difference in the previous section. What was the difference was like each LED was first turning on and off. Now we have made the code in the we have just changed with the thing. Now all the LEDs will be turning one by one in the each section, and then they will be turning off in the opposite direction. So this is the way how we can basically create patterns with the LED, and like sometimes which I always use like in the Diwali purpose, I don't buy the LEDs in the available in the market. I used to make my own patterns in that. So you can build that thing as well. This is the fun with the electronics or the embedded system. You can do anything. So this was the second example. This was another pattern of that. Now in the third section, we are having the pattern of odd or a even system. An odd and even system, like we are having 5 LEDs. So in the first section for first 1 second, the odd LEDs will be turning on. So in this case, the pin number 3, pin number 6, and pin number I guess 10 will be turned on. And in the second case, for the next second, the pin number 5 and pin number 9 will be turned on. It's not like I'm taking the pin numbers to be an odd even system. I'm just taking the LEDs to be an odd even system. So we can use this thing in either way around. So like you want to use that pin number 3, 4, 3, 5, 9 to be turned on, you can use that, and you want the pin number 6 then to be even, you can use that. It is totally up to you, your choice. Just with the difference, but we are going to code over here. So for that even odd pattern, what we are going to do, we do not require these extra delays except for the delay which is in the last line. So for the odd pattern, what we are going to do is we are going to turn off this LED number 5 and we are going to turn off this LED number 9. Fine. And for the even pattern, just the exact opposite thing we are going to do. We are going to turn on pin number 9 and we are going to turn on pin number 5. Let's just copy this up. Before that, you can even, if you want to verify this, if there is any mistake in that, you can. Done compiling, so it shows we haven't done any mistake in this. We can go ahead with that. So you can see we are having an odd even fashion pattern, like which we see in case of the emergency vehicles. Like if we just change with the color of the LEDs with like the blue and the red combination, then you can have this pattern as well. So these are the basic 3 patterns. You can work with multiple patterns you want to have. You can generate any random sort of pattern you want to generate. Just you have to make the logic into the loop section, like which pin you want to turn on first and which pins you want to turn off first. That is the main logic. And with this delay functionality, you can basically have that difference as well. Fine. So if there is any doubt till this point, you can ask. Else we will be moving to the last example of this exercise, over which we are going to turn like we are going to control the intensity of these LEDs, which is basically not very much visible in the simulation, but well, when we apply that similar code into the hardware itself, that is very good visible. Like the visibility and the actual performance is very good visible, like experience over there. Fine. So if there is any doubt, you can ask. Any doubts? Anyone?
No, sir, you can continue.
Okay. So the next thing, which is the PWM control, which I was talking about, this is the main reason why we have used that particular number of pins, pin number 3, 5, 6, 9, 10, and even the 11 one, because these all are the PWM functionality. So this is what the PWM signal is. Like when we consider the normal digital pins, like the pin number 0, 1, 2, or 4, or your 12 or 13, what they goes through is like when we just put a low, then they are just going to put a 0 volt supply at the pin. When we just put that in the digital write section, when we just put that to be a high, they are just going to give a 5 volt section, which is the 100% duty cycle or a 0% duty cycle. But in order to basically control that intensity level of the LEDs, what we require is to change this duty cycle. Fine. And in this case, the PWM functionality is help for us. It will be helpful for us. So suppose if we want to basically to turn on the LED to the fully like full charge or to the maximum brightness, what we can do, we will be passing a value of 255, which we will be discussing how this 255 is coming. Fine. So these are the 3 values, like we will be working from the 0 like intensity to the maximum intensity, and how that is going to work we are going to see in this case only. So like what happens is that like the functionality with like we have seen with the digital write. it is either going to be giving this kind of a pulse or this kind of a pulse. Fine. If we want like to modify this amount of time this pulse is high, even we are supplying a plus 5 volts, then that is your PWM functionality, the pulse width modulation. Fine. So to in order to use that functionality, we use this function, the analog write function. Fine. So the analog write function is going to take two parameters basically. One is your pin number, and the second is the amount of intensity or amount of duty cycle you want to send to the LED or to the pin itself. Fine. And since our Arduino is a 8-bit processor, microcontroller used in the Arduino, so the maximum value which it can store or we can pass into the analog write section or analog write function is 255. It's 2 to the power 8 is your 256 total values. From 0 to 255, it's your 256 total values over there. So you can see if we just want to give 25% of brightness to the LED, we can just send a value of 64. If we want to give a 50% bright LED, we can just send a 127 value. Fine. If we want to send like a 75%, we can send 191. So in this way, we just like there can be an error from 1 to 2%. Like the value can vary from 190 to 192. So it's just because every LED, every manufacturing process will be different. Like there will be a difference with every LED. So it not be like always possible for every LED the same value might be working and the same intensity. Fine. So this is how this basically the PWM functionality works. So let us start and let us see how we are going to do this. And for this, like the whole functionality will be same. The core, the connections are going to be same. Just we are going to change in the loop section. So let us just remove this thing up from here, and then let's add the code for this part. We don't require this as well. What we are going to do is we are going to apply another loop, which is a for loop in this case, because in this we are known how much time for how much time we want to run that loop up. So that is the main reason why we are going with the for loop in this case. So in the for loop we are having for int I equals to 0. This is going to be the intensity value which we are going to pass into that which is basically the duty cycle value which we are going to pass into the analog write function. Fine. So we want that to be starting from 0 and go up to, let us suppose we just put that to 250. Not like we are not considering it will be going to the 255, because like with the 5 value it is not going to put a very much difference with the output itself. And then we are just going to give, like we want each step to be changed by a value of 10. Like after every iteration, after every loop execution of the block of the for, we want the I value will be increased by 10 every time. Fine. So let's just add in this the code. Over there, when we used to turn on or turn off something with the for the LEDs, we use the digital write command. Fine. For the PWM functionality, we will be requiring the analog write function. It is also going to take two parameters. So in this case, we are having a parameter 3, which is our pin number, and the parameter I, which is the value which we want to send from 0 to 255 for the right amount of intensity which we want to see. So what is going to see, we are going to see in this loop is like this will be starting from 0 value, like the intensity will be 0 and it will be gradually increasing to the maximum value of 255. Basically it will be 250 and the difference will be not be very big for that case. We're just taking the consideration of a maximum loop power, and that is the main reason only. Like with the increment of next 60, we are coming will be coming out of the loop. And if we just take a value of 5, it might not be very easy or easily seen into the simulation. But when we do with this similar thing with the hardware, the difference can be seen very easily. So let's just copy this up for 5 times. And let's just put a delay. Okay, so let's have a half-second delay. That will be good to have. And this is going to be 5. This is going to be 6. This is going to be 9. And this is going to be 10. Let's just verify this code up, whether we have done anything wrong or not. So done compiling. So it shows we are good to go. This thing into the code section and simulate. So you can see we are having a minimum value of the LED brightness, and then it is gradually increasing. This is the maximum one, almost to the maximum one, and then it starts to goes to the low section and then restarts with the same thing out. Fine, everyone. So this is how we interface a LED with the Arduino. Now, when we are going to like interface a relay as well, 90% of the thing is same, just with the connections are different. That's it. The code remains the same. The thing you are able to do with the LEDs, except for the PWM functionality, because that will be requiring to be directly the thing which is directly being, like considered to be an LED, because the relays, some relays are not that much fast to operate. Fine. This is the main reason. Otherwise, any other functionality, you want to generate patterns, you want to turn on anything, you want to turn on in a row, you can do with that with the relays as well. The code will remain the same, just the connections are different. Fine. So if there is any doubt with anyone, you can ask. Otherwise, we can move with the next topic. Anyone having any doubt?
No, sir.
Are we good to go with everyone?
Yes, sir.
Okay, so So the next thing is we are going to interface a push button with the Arduino, like how we can basically use that simple thing with the logic. The main thing why we put this push button into the like IoT purpose thing is like there are many cases we can use directly push button for the user interface as well. And secondly, the logic how the push button is going to be used will be the same logic when we are going to use like a pin or basically the button onto your like smartphones or laptops or anything you are going to use for the controlling with the internet itself. The logic remains the same, just with some extra like things or functions which we are going to add in that. That is the main thing. The logic remains the same. The logic remains as basic as it is in available with the push button. That is the main reason why we have included this thing into the interfacing. So what is basically a push button? So a push button is like a switch. Whenever we are going to press this plastic case downwards, it is going to create a short circuit connection between these terminal AC and the terminal B and D. Fine. So these push button can be used into two cases. Like we can use that to be a pull up device. When you want to use it to be a pull down device, we can use in any case around. Fine. The main functionality of the push button is to provide a user interface. Fine. So let us see how we are basically going to use it and what are the different ways we can use this thing. So for this purpose, we are going to basically like one thing more over here is this terminal, like the two terminals will be going to be short circuit together, and rather the other two will be like the terminal A and C will be short circuited and terminal B and D will be short circuit. The internal connection will be short circuit whenever we are going to press this button up. This is the main thing. Like if we are going to press this button, if you use this pin or this pin, that remains the same. It does not going to make any difference. Fine. So in this case, like for the interfacing, we will be requiring an Arduino Uno with the USB cable, LEDs, jumper wires, breadboard, 220 ohm resistor, a push button, and a 1 kilo ohm resistor for a pull down operation. Fine. So for the LED purpose, the connections remain the same. You want to change that thing out, you can definitely go with that. And for the push button, what we are going to do is we are going to first insert that push button into the breadboard, and then we are going to first connect the first terminal, this terminal, with the 5-volt supply, and the second terminal will be first be connected to the first like the first terminal of the 1K resistor, and also this terminal will be connected to the pin number 2. Over here we are going to use the pin number 2 as an input pin. Fine. This is the main difference with the like the when we just required to interface a single LEDs, or we are going to interface a push button with that. Just this is the only difference. Rest the thing remains the same. So we go to the coding section. So in the like coding part, first what we are going to do is we are going to turn on the LEDs in only the case whenever the push button is pressed. So in case like we are holding that push button, the LEDs will be turned on. And when we release that button out, the LEDs goes off. Fine. So like this is the first task for us. Let us do that thing as well. I'm just putting this thing as in like we are going to use these things. So let me just put out of first for the loop. After that we will be using this. So first of all, like we are having our LEDs with the PUN mode, and now we require an extra pin for the push button. For that we require again the pin mode, and we are going to use the pin number 2 in this case, and then we require it to be an input. So this is the main difference. Now what we are going to do is we will be going to create a variable, and this variable will be of a type int or a integer. So that variable will be going to store a value to tell us whether the push button is pressed or not. Fine. So how we are going to do this, like as we have seen in the diagram, we have connected that thing to the pin number 2, which is a digital pin. So what we are going to do is we are going to read that pin as in digitally. So for that we require a command which is digital read, and this is going to take a single parameter which is your pin number, and in this case it is pin number 2. Now there can be two cases. The first case is the push button is pressed. When the push button will be pressed, this is going to read for a 5 volts high supply, which is a value 1 or a value high. Fine. So in this case, what that means, whenever this val value will be equal to high, we are going to turn on our LEDs. Fine. And whenever this val value is going to be low or 0, we are going to turn off our LEDs. So in order to basically check for the conditions, we use the if statement. And in this case, what we are going to do is we're just going to check val equals to high. If it is, then go to this section of loop and basically turn on the whole LEDs. Else, if this is not a part, Then what we are going to do is we are just going to turn off the LEDs, and if we can take with the consideration, we can just put a small delay after checking the value to be make sure, very small delay of around 50 milliseconds. So this is our code to basically turn on the LEDs whenever we are going to push we are going to press that button out. As long as we are pressing that button, the LEDs will be turned on. Just going to verify this for that. So it shows done verifying and done compiling. So that means we haven't done any error. Let's just go to the simulator and first put our components over here. So this is the push button, you can see. So we have this terminal A1, terminal 2A. This is going to be making the circuit out. So A1 and B1 are internally shorted together, and 2A and 2B are also be shorted together. So whenever we are going to press this button out, this A1 terminal will be connected to this this 1A terminal will be going to be connected to 2A terminal. So according to the diagram, we require a resistor as well, and this is a 1 kilo ohm resistor that will be fine for us. Now let us just have a gray wire from this side, and we are going to take the signal from here to pin number 2. Then what we require, we just require a 5-volt supply as well from this side to the push button as well. Let's just copy this up, go to the code section, paste this thing, and let's just start with the part. So since our push button is not pressed, it is not turning on the LEDs. As we're going to press this push button, as long as I am going to hold for this, the LEDs are turned on. As I release it, turn off, on and off, on and off. So this was our first example, and if there is any doubt, you can ask. Anyone having any doubt?
No, no, sir.
Okay, so the next exercise which we are going to do with this is like, what if I want like to turn on and off these push buttons with a single, like these LEDs with a single push button. So how we can do that? Let's just see how we can do. So for that, we are just going to create another condition to check what was the state previously in for the LEDs. Fine. And for that, what I'm going to do is I'm just going to add a boolean variable. Sorry. Okay, I just got it wrong. Okay. A flag variable. So I am basically, what I am going to do is I am just going to pass a value of false in it only for the first case. Now what I am going to do is I'm just going to shift this from the val section to the flag. Now what is going to happen is whenever this flag is going to be true, whenever the value of the flag is going to be true, the LEDs are going to be turned on, and whenever these flags value will be going to be false, these LEDs will be turned off. Fine. So we are clear with this point. Now how we can control this thing with the flag, and this is going to be telling us the status of the LED previously, like, or basically at the present what is the status. When this means if the flag value is true, that means the LEDs are turned on, or if the flag value is false, at present the LED is turned off. Fine. So if we change this flag value, we are going to change with the uh, status of the LED as well. So how we are going to do is we are going to use again this same thing, int var equals to digital read pin number 2, and we are going to basically put another if statement with if val is equals to high, then do one thing, take the flag value and put the flag value not of it. So this what means is, like, if the flag is true, put a value of false into it. Replace the previous value with the true value or the false value. So like if previously it was false, it will be changed to true, and if previously it was true, it is going to be changed to false. And with this, with a single button, we are able to control the status of the LEDs, or basically to control, like to turn on or turn off different LEDs with the simple single button. Fine. So let's just verify this thing up. Control A, going to the code section and start for the simulation. So as I click for one time, it's turned on. Okay, I am again getting this thing. Okay, I don't know why this always happens with the simulation. Let's just change it a bit. If flag equals to is it this because of my mouse or anything else? Just a second. It's not considering that thing up. Again, this is going to be giving a glitch with the simulator. God. Let me see what I can do with this. If I can have it. If we have done the code in a correct way. It's not responding. Let me just check it if we can have in a different way out. This is 0. This is to be flag to equals to no. Let us just increase by 1. If flag equals to 1, this equals 1, do this. Else flag equals to 2, then do this. And 200. So you can see like we are having a 1 and a 2 value. That is the main reason why we are not like it's not taking properly into the simulation. So that is why we are failing to do that thing up in this. Okay, let me do. I have an idea for that. Play for 500 milliseconds. So this is pretty good. We can just move back with the code. So what we are going to just change with this code is we are just going to put a delay in that of 500 milliseconds. Let's just see if we can see with the distance. So on our first click, we are going to turn on the LEDs, and on the second click, we are going to turn off the LEDs. The next click might be taking you a while because like we have put it this 500 millisecond delay. So this is the like thing, like there are always a pros and cons for using some particular thing. Like whenever we are going to face this push button into the simulation, there are some chances even if you're like your mouse is not working properly, so it is going to give errors. So for that to give that compensation, I have used a delay. You might require in this in like when you are going to have with the hardware, you can use it, or even that like you can just skip it this thing. Like I never use this delay over here. Like this is this 50 millisecond delay is for a specific reason. Why specific reason? Like whenever we like presses the push button, it is not like in the case like the voltage supply drastically changes like in a very short span of time. It changes from 0 to 5 or 5 to 0. It takes time, and that for that thing we have to change, or we have to give the microprocessor that time to basically give that push button the time for stabilizing the voltage. Otherwise we will be having pulses or like spikes into that, which will be giving the wrong values. But because of the simulation error, we might require this delay as well. Fine. So this was the part, like if we want to turn on or off with a single of or multiple LEDs with a single push button, you can do that as well. So if there is any doubt till this point, you can ask. Otherwise, we will be going with the very simple topic again after that. If we are good, if we are all okay with that as well. Anyone having any doubt, please let me know.
Sir, is it okay if we left that two pins of push button?
These two.
Yes, sir.
Yeah, this like if we connect this thing over here, this is the going to be give same thing out. Like if we have connected this 5 volts over this pin, the 5 volts will be available on this pin as well. These two pins, like pin number 2A and 2B, are being internally connected, and these two are 1A and 1B are internally connected. So we can use anything. So it will not be putting any much more pressure to that or a difference to that.
Okay, sir.
Yeah, like we can consider this thing like we are putting that thing to an open ground, and they can like these are leads, and that can be considered to be the antenna purpose for the electromagnetic waves. There are some cases, but since we are putting that thing into a breadboard, so this is not in a like more of a like serious case for this project or for this interfacing. Fine.
Okay.
Anyone having any doubt? Any more doubts?
No, sir.
Okay. So if we are not having any doubt, so we can, I think we can move with the next part. This is a very simple topic, very simple. How to basically interface a potentiometer. Like this is going to be helping us to know how we can basically get the values of a analog sensor as well. Because to take a value from the analog sensor or to basically interface a push button is almost the same thing out. We are not going to have any kind of difference when we are going to interface a soil moisture sensor or we are going to interface a potentiometer. Just what we are going to do with that value is going to make the difference. How to take that values will be remaining the same. Fine. So let's just see with that as well. So another thing, if we consider a push button or sorry potentiometer or a joystick, both are almost the same thing, just with the difference the joystick will be having two potentiometers in it for a x-axis and for a y-axis, and even some joysticks are also having a switch as well. This is the only difference with a joystick and a push button. So if you are able to interface a single joystick, you will be able basically a single push button, you will be able to replicate that thing for two potentiometers as well. Fine. And if we are able to interface two potentiometers, then that means we are able to code for a joystick as well. Fine. So let us see how, like, what is the push button. So the push button is basically your variable resistor. Now these are the basic sizes, these are the basic symbols or like the components which are available in the market, from starting with these small types to this bigger ones. And this is like all these are the rotatory ones, and then this in the middle section is your linear push potentiometer as well, like with with a distance, with the length, the resistance value will be going to be changed. Fine. And in the rotatory section, with the rotation of the knob, we are going to have a difference in the output voltage. Now the main thing which we want to know about over here is the Arduino is neither able to measure for the resistance, and it's able to measure for a capacitance. It is only able to measure for the voltage. So what we are going to do is with this potentiometer, we are just going to divide or basically change that voltage, which is it is going to be sensing, and that resistance value is going to be translated into the voltage value itself. And similarly, whenever we are going to interface with that soil moisture sensor as well, that capacitance value or the resistance value will be changed into the voltage, and that voltage difference or the voltage available with that at the end of the analog input section is going to be used by the Arduino for the coding part or whatever we want to do with that. Fine. So this is the basic symbol of like how a potentiometer will be looking like, and we will be having three terminals for the potentiometer. The leftmost end and the rightmost end will be used for the power supply. So like you can use either one for the 5 volt supply or the ground supply. Like since it's a resistor, it is providing the resistance. So the connection area will not be giving into that much matter. And like if we just swap the things out, like if we connect the positive end to this side and the negative end this side, the value will be different. Fine. So like it can be the case if we connected A to be the positive terminal, then this can be the highest end or this can be the lower end. This will be going to give 0 volts as an output, or this going to give a maximum 5 volts as an output. And with this swap out thing, this reverse will be happening up. Fine. And the central pin, the pin number B, which is the wiper pin, which is going to be helping for the exact value which will we are going to use for the taking the value, like at which position your potentiometer knob is at present. Fine. So for the interfacing, we require an Arduino Uno with the USB cable, jumper bias, breadboard, and a potentiometer. So like as I have told you, like the center pin is going to be the wiper pin, and it is going to be applied to the analog pin of the Arduino. Since it's not a digital, we are going to check for each value, each iteration, and that's why we require analog pin for that purpose. And that analog pin is being attached to a analog to digital converter. So we are going to have a value from 0 to 1023 because of the reason the resolution for this A to D ADC is of 10 bits. Fine. The other two pins are being connected to the power supply, 5 volts, and the ground. Let's just see for this, and this is over where our serial monitor is also going to help us around. Let me just remove this push over here, and we might be using these LEDs as well for this case. So what we require for this case is we require the serial monitor to be available because we are going to read that values what the potentiometer is giving to the Arduino. So in order to read that, the basic default functionality which we can use for this is the serial monitor. Now the serial monitor will be beginning like we have to first initialize that thing, and for that we have the command serial dot begin, and it requires a parameter to be passed into it, which is the baud rate, and we are going to use the 9600 baud rate as default. Now the second line is an optional line. You want to use it, you can. You want to skip it, you can. Since because of the reason are like your analog pins are going to be your only the input pins, so doesn't matter what you are going to put it. The Arduino like the compiler will be taking that to be a default function as an input analog pin. So if you want to put this thing as like pin mode, just make sure this is to be the main difference. A0, like for the other pin for the digital purpose we use pin number 0 1 2 3 4 5. Doesn't matter, we do not put a D with that, but in case when we are going to use with the analog pins, we have to put a before that as a prefix to that number of the pin. Fine. So you can use this as input. This is an optional line, you can use it. You want to skip it, the function remains the same. Now what we are going to do is we are going to take a val variable of type integer, and we are going to store the value which is being read by the Arduino from the potentiometer. For that, since it's a analog value, we require analog read functionality, and for that we like this is also going to take a parameter like similar to our digital read, and this parameter is the pin number. In this case we are having pin number A0. Then what we are going to do is we are just going to serial.print ln like this. If we just print the thing out, if we just write this command serial.print, this is going to print into the same line. If we want the next value to be printed into the next line, then we use print ln. Fine. Now in this we are just going to have the, let me just show you the difference as well. So for the print we are going to like write, this is the how we write the strings into it into the serial monitor like we have done in the yesterday as well. Value equals to space, then we are again having a serial dot println, and what we require is the val value, and just put a very small delay of 10. This is an optional delay, you want to do it, you want to skip it, you can, doesn't matter. So this is the code. Let's just copy and paste this. It's not copied up over here, and bring a potentiometer from this side as well. So what we require is our like this is a 250 kilo ohm resistor potentiometer. You can change this value as well. You want to change it to 10 kilo ohms, you can do it. Let's just connect the first terminal to ground, the other end to 5 volt supply. Let me just change the color so that we are able to see this difference. And the center wiper pin is going to be our A0 pin. Fine. So let me just change this thing. The LEDs will not be used since we are not basically putting any code for that. So as we run this up, you can see it is in the 0 position. I am not using any LED, and also you can see the print and the print ln difference. Like the values equals to 0 is the value which is also being printed in the same line, and then we are having a next new line character. As I move this potentiometer into the direction, you can see into the change into value. Fine. So this is how I just basically interface the potentiometer. Now we are having these values, and if we want to do something with that values, we can surely do that. Suppose at this is the middle point, and if I want after 511, after this middle point, I want to turn on my LEDs. So how we can do that? Let's just code for that as well. We just bring that val functionality as well into this. Let me just have this val functionality, and if this val value is greater than 511, turn on the LEDs, otherwise just turn off the LEDs. Fine. And we just require these LEDs to be into the functional mode as well. We need to tell that thing as well, so we have to put this thing in the upper section as well. Let's just simulate this thing up. Okay. Okay, we just, so you can see whenever we do any error, this will be highlighted. So what is the error? I used a variable called value, which is not available in this. We just have a value, val variable. So just, I'm going to change this thing from this side. So you can see I am having the value of 511. It's not turned on since I have set for a value greater than 511. As I put this, anything greater than that, it is going to change the value to the 593, and this is going to turn on. Anything less than 511 or 511, we are going to have a off. Fine, everyone. So basically like this is what we can have. Also, we can have the functionality. Let me have it as well. Suppose I just skip this thing off. I have a RGB LED in my case. So I guess 3 pins will be sufficient for that. This is my RGB LED. Cathode, red. So this is the ground end. This is the red end, blue, green. Okay, let me just put it this way. I don't want this, I don't want this, I want this. The cathode is connected over here. We are having blue connected to this side. And this is over here. Fine. So what we are going to do is we are just going to divide this thing up. Pin number 3, 5, and 6. Okay. We just remove this up. 3, 5, and 6. Oh, sorry. What we are going to do is, in this case is, I'm going to change the value of the potentiometer, and we are going to change the color of the LED as well. Fine. How that will be happening? Suppose the value is less than 500. You can use any range in this. Anything less than 500. What we're going to do is we are going to put this value to be a green. Like the LED will be going green. So for that we are just going to have this low. Else if Next condition is going to be like less than 500. If the value is less than 500, the green LED will be like this RGB LED will be showing the green light. Otherwise, otherwise, if value is this val is greater than 500, and val is less than 1000. Fine. If that is the case, what we're going to do is we're going to turn on 5. Basically, we're going to turn this to be blue, and in the rest case, what we are going to do is else if this is greater than this val value is greater than 1000, then we are going to turn on the red LED. So this is what we are going to have in this case. So you can see the value is less than 500. We are having a value of max, like the value is less than 500. So with our code, what we are seeing, the green LED should be turned on since the pin number 3 is for, let me just have it. Pin number 3 is for green. Pin number 5 is for blue. And pin number 6 is for red. I have used the RGB LED. You can use 3 different LEDs as well. This will be similar for them as well. So, like the value is less than 500, we are having a green color. As I increase the value to greater than 500, we have having a blue color. As I increase the value to greater than 1000, we have a red color. Fine, everyone. So this is how we can use this potentiometer value to control anything. And with this thing as well, whenever we are going to have that soil moisture sensor, we will be using that value sent by the soil moisture sensor to basically control the pump system to automatically irrigate the system or the soil over here. Whenever we are going to like when we are going to like basically like how a smart irrigation system works. We require a soil moisture sensor, we require a pump system with a relay and a controller. When a particular limit of moisture is dropped to up to a particular limit, after that, we require the pump to be turned on. This sensor will be going to help us to detect that value when the minimum threshold for the moisture is touched. If it is touched or if it is below that, then we are going to turn the pumps automatically on. Fine. So this is like how some simple things will be going to have an embedded system. And if we are putting that data to the remote servers, remote databases or to the user, and if we are also providing a user interface to basically tell user like that is below that point, you can turn on the pumps. This is what is IoT is. If it is able to turn on from anywhere, any around the world. Fine. So till this point, if there is any doubt, please let me know because we are done with our today's work. Anyone having